Good afternoon, everybody. As for the publication, I have the plan to show my viewers who join online the concept of smoothening the pulsating DC using a capacitor. In connection with that, I have got my device ready. For that, I need the transformer and rectifier system, and I do have oscilloscope with me. All of you can see, as we have discussed time and again, the transformer provides always alternating current because of mutual induction. And here the oscilloscope simply confirms that because we all have studied it and we have verified the graph in pictures in books and by our teachers on blackboard. But here the real oscilloscope confirms that. So wherever I have connected across the terminals of the transformer because at this point it is not getting easy for me using a single mobile and fixed in its position. I have shown only the oscilloscope, so you please do not mind that I am manipulating here. The oscilloscope probe I have connected to 0 and 6 terminal of the transformer. So as we have discussed, the same thing we have observed here. And for your information, I will remove the oscilloscope probe and you see the graph will be changing. This confirms that the oscilloscope was taking the real measurement. And now, for your information, I show you the probes of the oscilloscope signal probe. These pointers, rather the clips, are used to connect at various points of the circuit. So, for example, after confirming the sine wave curve, I now take it to connect the rectifier point. We had discussed that the bridge rectifier is a full wave rectifier, and accordingly I connect, and you just see when we complete the connection, you will see on the curvature this is coming. There are various adjustments which I have to learn also. So immediately everything will not be settled. Now what I want to show you, I change again the point here. How do I show it? I show it like this. You can see this is the output of the rectifier. That means the graph says all the upper halves of the sine curve have been added by the rectifier. See, let me change some scales. This is the idea how we understand the curves after the rectification process. This is the curve shape. And now I have got a capacitor. I show you here. This capacitor, I will now post it, and the moment I post the capacitor, you see the curve will be getting changed. So how is that getting changed? That is our target today. The positive will be connected to the positive, and the negative will be connected to the negative. And this is how I show you using everything that I have connected the capacitor here on the breadboard. And after connecting the capacitor, you just see the pulsation stops. This is truly beautiful and something amazing, because what role does this capacitor play here? We could get the idea from the curve itself. I now remove and you see there is a change. So please think over it. Things are miraculous in science as we reveal through systems, devices, equipments, not by reading. And now you just see this bridge curve, rectified curve, is I told already is a pulsating DC, and for lighting purposes, you see through the camera lens, you will observe this LED has got slight flickering. You can observe, but I cannot observe here. You can observe at your end. And when I connect the capacitor again, you will observe this flickering will be changed. I hope so. You have to confirm me. This flickering will change because why the light flickers? Because of the pulsating DC, this LED flickers. Now, when the pulsating DC becomes a smooth DC, so there is no chance for the LED to flicker. In this connection, I want to inform you that again in another program, we will add another component for best smoothing purposes, which we never come across in any ready-made commercial gadgets like battery eliminator. That particular component which we will use and study it again using oscilloscope. Smoothing has got a upper limit which we should understand what is that upper limit, because each and every time you analyze the data, I will just show you now. Please wait. I do have a battery and I will connect this terminal of this particular battery to the clip of the oscilloscope, and you will observe how is the DC curve. That is very important for all of us. to observe again. So this was all about rectifiers. And now I connect the battery in your front. How I connect, you see, positive connected to positive, and negative I connect direct. And you just see, I think this is discharge. Otherwise, this line should have gone up, indicating the voltage. See, if you give me 1 minute time, let me bring the weight. This battery is a new one, and let us test it. How we test? I have to connect and you have to see. It is shifting little bit. So that is what we wanted to discuss today, how things behave. Let me use channel 1. It has got two channels, and I will show you the behavior. See, you can use two terminals at the same time. See, the pulses which we see is from our body. The pulses from the body you can see that are displayed. So our body receives many signals, and they are getting displayed. So this was the idea about observing oscilloscope, and I show you the different features on this oscilloscope. We will discuss one by one. It has got two channels. Two channels means two probes can be connected. The probe is like this. This is the probe. It will be connected to the port, and thereafter your clips will be connected to. This is all about the study of curve character using oscilloscope. Let me return again to our pulsating DC. Let us observe after removing the capacitor. See, many often the curves do change like this. So in the next class, I hope you will enjoy more about other curvatures and the special component that we will use for smoothing to the upper limit. So I do not know exactly how did you enjoy or not. Again, the same problem. Let me use the channel 2 and I show you finally before we leave, because channel 2 is something automatic. So I can show you finally before we leave. See, different variations are there which we need to acquaint by ourselves for a better knowledge. You can see how they behave. Slight variation will create a big change in the curve concepts, because a lot of adjustments are there which we will learn gradually. I will help you also, all of you, those who are interested, no problem. We will come across one by one, but in a single day program, we will not be utilizing all the aspects. But anyway, I'm happy that today we use this for the first time. Even I have used this for the first time, so that is why little bit of variations we have to understand, and gradually I will be getting you acquainted. Thank you all for joining this live program, and hope we again meet tomorrow.